Okay, good afternoon, everybody. Welcome to the Edgerton Explore It Center. We are doing our Let's Explore It today. We're working under pressure. How are you under pressure, Deb?
I'm going to be sweating under pressure.
So we have talked about a few other areas that we do with pressure. Today we're going to do a few more little fun experiments. So the first we're going to have Deb show us a standard. We have a little vacuum chamber. So she's going to show us how it works.
All right, so with our little vacuum chamber, there's a little valve up here on the top. I've already blown up a balloon inside the vacuum chamber. We can kind of look at that real closely here. So there's a little balloon, and we are going to see what happens when, not necessarily that I'm going to add air into the chamber, but I'm going to take the air out of the chamber, and we'll see how that affects our little balloon inside of the chamber. Okay, so with this we have a little pump, and there's a little valve on the top. We're going to place that over the valve.
Hey Deb, stand right behind it, because with your jack, like make sure you are standing behind there. It's hard to see the balloon. Yeah, your backdrop.
All right, we're going to start pumping, and this is not adding air in, we are taking their air out. Now watch carefully at the balloon, all right? You might see something happening to the balloon.
So what you can see as Deb's pumping the air out of there, we're decreasing the air inside of our container. The balloon is getting larger.
It's also
getting more difficult to remove any more air with the pump that we have.
okay, so if you recall the size of the balloon before we started, now look what happened when we took the air out. The balloon inside actually filled up with air. Now, I didn't add any more air into that balloon, but it looks like I blew it up. So when the air on the outside was taken away, that gave the air inside of the balloon room to expand. So it actually looks like we blew up the balloon. Now, there's another cool thing about this. If I push the valve on the top and I let the air back inside of the vacuum, what do you think is going to happen to the balloon? This is where we do the experiment, okay? So I'm going to release the air or turn the valve. Watch carefully what happens to the balloon. Okay. The balloon shrank. So the air pressure that went back inside now makes the balloon shrink, actually, or the air pressure is stronger on the outside and makes the balloon go back to a smaller state. So there we have what happens in a vacuum.
So we're going to do a little bit more with that with our bottle. So we have a sport drink bottle because it's rigid, and what we can do is we can try and inflate a balloon inside of a bottle, and we'll see what happens when I try to inflate the balloon, and it's firmly secured on the lip of the bottle.
Were you blowing?
I was blowing as hard as I could. So, kind of like our little vacuum chamber, I was exerting more pressure on here, but there was pressure built up inside of the bottle, not allowing the balloon to react to the pressure I was putting on the inside of the balloon because there was pressure on the outside of the balloon. Now, a little sleight of hand trick if you wanted to impress your friends. So now we're going to make something a little slightly different, and you'll see it react differently.
You were actually blowing up the balloon.
I blew up the balloon, and now the balloon is staying inflated without me having my mouth on there. The trick of this experiment is,
Oh, let me see here. If I blow up my balloon. Okay, so I've got a balloon, but the end is open, right?
right,
So if I let go of this,
it goes out. But this one is staying inflated. So what is different about our bottle, we got this ready beforehand, is that we have a hole in it. So when I have my finger over the hole, keeping the air pressure in here, and this is if there wasn't a hole in here either, but in order to do the full experiment, we had to pre-drill the hole. It creates added pressure in here that doesn't allow the balloon to expand. When I was inflating this now to get it larger, I had removed my finger from the hole, and now to hold it this way, if you watch closely, I'm going to take my finger off the little hole, and you can see that the balloon shrinks because the air pressure is allowed to become the same on the inside as it is on the outside of the bottle. So now I'm going to cover up the hole. I can't get the balloon to expand, and it goes back to its normal size. If I remove my finger from the hole,
and you seal it off.
and then I seal it off, it creates that pressure and there's a slight vacuum because this balloon, being elastic, wants to pull back to the mouth of the jar, but the air pressure, or vacuum rather, is not allowing that to happen until I release my finger from the hole. Now you see we have this other jar here. It's a 2-liter soda bottle. We have a balloon in there as well. There is a hole that I made. There it is. I gotta make sure I know where it is. So I can do the same thing. I can exert a little bit of pressure on the inside of the balloon, but there's too much air pressure in here for it to inflate. Now, if something different will happen with this one, and you'll see why in a second. So with this one, when I sealed off and the balloon wanted to create a vacuum, the walls, the plastic of the bottle itself is not strong enough to prevent the balloon from pulling back and deflating once I exert the pressure on the inside. There's a little bit of pressure left there, but for the most part, we've collapsed that bottle because of the vacuum exerted on the inside.
Kind of like going into space. So when we're in space, the astronauts have their spacesuits.
Right.
And they are pressurized so that they can maintain the outside, their pressure so that they're not crushed.
Right. And part of this demonstration is part of our space flight demonstration that we talk about what astronauts have to do differently, having their pressurized spacesuits. They're not just a fancy white suit they get into. Well, they are really fancy in that regard because they have multiple layers that do lots of different
They
things.
keep them warm, they keep them from getting too
Protected
hot.
from the UV and all those things, including exerting enough pressure on them when there's less pressure and less gravity in outer space.
Otherwise they wouldn't be able to, they'd be crushed.
Yep,
Yeah.
absolutely. So our last thing that we have for us today is a fun one, and it involves a potato. So typically, if you wanted to put a straw into a potato, it really wouldn't. Oh, I lost the whole potato.
Hot potato.
But it's cold. It doesn't work. I have a broken straw. So using pressure, in kind of the same regard we use this, by capping off the pressure in the straw with my thumb, I'm then able to go right through the whole potato with the straw. A little piece stayed in there. We'll see if we can get another one.
If you want to make French fries.
So a fancy, interesting way to make French fries. And we have our potato chunk that's been cored out and removed from the potato. And so we're capping off the pressure. We're exerting enough pressure, it's staying constant in the straw, that it holds the plastic tubing, the straw itself, rigid so that we can grow through a raw, hard potato. And I keep losing the pieces. There we go. There's a little straw fry. They talk about shoestring fries. We're making straw fries today. Now there's too much pressure, I can't even go through because I have all kinds of potato chunks in my potato. So this is something, as long as you have a drink straw at home and a raw potato, you can try this. And now we got a couple different ones here in there. And you can play around with pressure. Try it 2 different ways to see if you can. This one I went in just a tiny bit, but the straw is broken, it's cracked. If you don't cap off the end, and then if you do cap off the end, you're able to go right through your potato.
Well,
Too many times.
yeah.
So that's our pressure for today. This one is another experiment as long as you have a sports drink bottle or a more rigid plastic bottle than a 2-liter bottle. It doesn't have to be clear. It could be a soda bottle or whatever. Water bottles probably are too thin. They would collapse like this. So maybe a soda bottle, or especially the sport drink bottles, are heavier plastic that you'll really be able to do this. I just took a drill bit and drilled a tiny little hole that I'm able to cover and release with this. Is something you can do, and you can kind of show it to your friends and be like, okay, hold it for them, put your finger over the hole and see if they can blow up the balloon. Or then when you do it, you can release it and they wouldn't be able to do the same effect for a little bit of sleight of hand if you wanted to. So that is our under pressure experiments today. I hope you enjoyed it. I hope you're able to try 1 or 2 of them at home yourself. Let us know if you do. We'd love to see your results. And we will see you next Wednesday. We are taking a little bit of time off from our presentation schedule for the holiday weekend. I hope you stay safe, have fun, and learn something this weekend, maybe? What else?
Of course. And always, if you do something, send us a little message or post a picture or whatever to us, because we sure would enjoy seeing some of the things that you guys have been doing out there too.
Thanks for joining us today. We'll see you next Wednesday. Have a great day.